Hello class, Mr. Knight here, and I'm going to share my insights for Lesson 3. We're 3 weeks into the course. I hope everybody's enjoying it so far. I know we've done a lot of Python programming just to get refreshers going, but now we're going to start pivoting our activities much more towards testing. And this week we're focused on unit testing in particular. So what is unit testing? You may have heard that phrase before. It's very, very common in the industry. Unit testing is a particular type of testing in which we write test cases that will directly call the source code. And this is what we call white box testing. Our tests will be directly calling the functions, methods, and properties of our Python modules. And these tests are meant to be short and sweet. So if you think about from the previous lab assignments, you probably wrote some functions for things like sorting or for getting dates from Social Security, retirements. If you have those individual functions, each one will have a set of possible inputs. It does some stuff internally, and then it returns something out. With unit testing, we want to make sure that unit, meaning that individual function, works properly for different kinds of inputs that we put in to get different kinds of outputs. A good example I can think of would be something like, let's say, an absolute value function. If you remember from your math class, absolute value is a function that takes in a numerical value and returns the positive version of that value. So if you put the number 2 in, it's already positive, you're going to get 2 out. If you put the number -2 in, you should get a positive 2 out. Very, very simple function. So we could write some unit tests for an absolute value function. When we write these unit tests, though, we want to make sure that we cover a good set of input variations. But we don't want to overdo it. There's a fine balance. If we think about the different types of inputs we could put into an absolute value function, we could think of things like, well, I could put a positive number in, I could put a negative number in, I could put 0 in, maybe I could try to put in a non-numeric value and validate that it explodes, or maybe I should put a float value in and not just an integer. So all of those are what we could call equivalence classes, right? It doesn't matter so much or what positive number I put in to test, as long as I choose a good example from the set of positive numbers, right? If I put in a 5, it's not that much different than testing a 10. And so I don't need to spend my time testing all these additional positive numbers when I know that one positive number will be sufficient. So that's why we group our inputs into what we call equivalence classes. And just right here, we probably named about 5 different equivalence classes we could have for an absolute value function. Another thing we'd want to look at are boundary conditions. Boundary conditions are where equivalence classes meet, so to speak. So if I have that absolute value function, the perfect example for the boundary condition would be 0. Why? Because in the function, that's the place where the values will start to change. Positives become positives, negatives will change to become positives, and 0 is the special one where it's itself. So that's that change point, that boundary point. So absolute value is a pretty simple function, right? The functions for this week's lab assignment, though, are going to be a little bit more complicated. So make sure you're thinking outside the box in terms of what those boundary conditions could be and what those equivalence classes could be. Now that we understand what unit tests are, let's talk about a practice called test-driven development. Anybody can write unit tests for any code. You can do it by yourself as part of a school assignment, or you can do it as part of like an open source project, or maybe you do it in the industry as part of your regular development workflow. But this practice called test-driven development is meant to be a formal testing practice and a formal development practice where we use unit tests in a particular way. The purpose of writing unit tests is to deliver value to us. We want to make sure that we test our code so that we don't release any bugs. In school, typically that means you write your assignment, then you maybe write some tests for it, you test it manually, and then you submit it, you're done, you get grades, and that's it. Unfortunately, in the industry, your code is going to live a lot longer than just a week-long assignment. Right? You'll be developing products and features that could live for months to years in an active code base where other people are always making changes too. The purpose of unit tests is to be defensive. I should be able to run my unit tests on demand anytime a code change happens. And I'll know right away whether or not my changes broke something already there. The more unit tests we have, usually it's the better thing, because we have that much more coverage, we have more protection. And when it comes to test-driven development is a process that says you should write your tests before you write your code. Now this might seem backwards. Typically we would think, oh, well, I have to write my code first, and then I'm going to write tests for it after I have it so I can actually interact with the things. So why would test-driven development do it backwards? Why would we write the tests first? When you write your tests first, you're forced to think more deeply about the thing you're making. You have to think about the boundary conditions. You have to think about the equivalence classes. You have to think about the method names and the inputs and all the expected cases. It frames your mind as the developer. And the hypothesis is, if you can frame your mind better from the beginning, not only will you hold yourself more accountable once the code is out that you actually have your tests, but you're less likely to introduce bugs as you go about developing the features, because you're already thinking outside the box about all the what-if cases. So it's not so much that from the first pass of your test-driven development that your tests are going to catch bugs. I mean, they could, but moreover, you'll find most likely that you're going to be writing, your test cases are going to be passing as soon as you write your features, because you're writing your features the right way. That's the beauty of it. So with test-driven development, the process is when you have to implement a new thing, first you write your tests, then you write your feature to make the tests pass, and finally, third, you refactor your code to improve anything that could be wrong with it. And then you rinse and repeat. New feature comes in next, you write the tests, you write that feature, and you refactor. Move on to the next one. Write tests, write your feature, refactor. And that's all there really is to test-driven development. It can be part of any software process, whether that's waterfall, agile, or post-agile. You can do it by yourself. You can do it as a team. It's very helpful. So I encourage y'all, perhaps, as you are developing future assignments, that you would consider specifying tests before you write your code. So now that we've talked about unit testing and TDD, or test-driven development, let's shift our conversation more towards Python, because this is a Python testing course. Python, like any other major programming language, has a number of test frameworks. For our class, we are going to use one called PiTest. In my opinion, PiTest is the best Python test framework out there. And honestly, it's one of the best test frameworks in any language. I love PiTest so much. What makes PiTest really nice is that it's minimal. It's very Pythonic. You'll write your tests as functions. You don't need to write them as big classes. You don't need to have complicated setup, cleanup methods and all that. You'll use fixtures instead. But at the core of it, a test case is a function. And it's tight, short and sweet. You'll name it something test underscore, whatever the function name is that you want the test to be. And when you run PyTest, PyTest will scan your entire project directory for all of those functions and test modules and automatically run them. It's beautiful. You also don't need to worry about complicated assertion libraries. PyTest is designed to use Python's standard assert command. So if you want to assert something is true or assert something is false, just say assert this equals that, or assert this contains this. stuff like that. So you don't need to learn a new modular library. You just make Boolean conditions as if you were writing an if statement or a while loop. I will say though, for PiTest, it does have a little bit of extra installation. The PiTest module is not a standard part of the Python language. It's not part of the standard library. You will need to do a pip install on your machine to get PiTest, but that's it. Get that, you're done. So, that's about all I want to say for now about unit testing and PiTest and TDD. Throughout the week, have fun with your lab exercise. You'll be writing some tests using PiTest for some of the previous lab exercises. I hope you all have fun with that. If you get stuck, please don't suffer in silence. Please reach out to me proactively. I'd be more than happy to assist in however I can. So happy coding, everyone, and happy Labor Day.